welcome to Behind the Science, where we ask challenging questions directly to the scientists who are trying to solve today's toughest problems. I'm your host, Jen Fournier. Today, I am putting my detective hat on. I have learned how to figure out what glycans I have, but I also need to know where they are. Just like in released N-glycan analysis, glycan occupancy and linkage information is critical. The problem is I have so many options to get the answer. For example, I could do intact protein analysis, glycopeptide mapping, or subunit analysis for my monoclonal antibodies. Each has different methods, columns, and instrument options. It's really like putting the pieces of a puzzle together. So in this episode of Behind the Science, I need a plan. Oh, and my hat. So join me as I investigate the best options to do this type of work. Artificial sugar, where is the real sugar? Oh, gosh. Oh, sorry, John. Sorry.
Jen,
Okay,
what are you doing? You look really frustrated here today.
I'm just trying to find real sugar to put in my coffee.
Jennifer, it's right in front of you.
Thank you, Bill. Didn't even look there.
You know, you're not the only one who's frustrated. I've been really challenged by customers who ask whether we have better ways to look at where the glycans are located on their glycoproteins.
You know, it's funny that you asked that because I was just on my way into the lab to find somebody who can help me with that answer.
Well, provided Steve will let us back in the laboratory after what happened last week, let's go in there and see whether he can point out a few things to us, okay?
Great, let's go.
You're all set?
I'm all set.
We're off.
All right. Hey, Steve. Sorry.
Hey, Jen.
That's the second time I've done that to him.
Steve, sorry about that. Are you busy today?
Sorry.
Oh no, I got a few minutes.
You know, we just spoke a few moments ago about glycoproteins and where they're located, and I can get really long-winded about this stuff. Do you have a couple of minutes and can you help?
Yeah, I'm pretty sure I can do a better job than you can.
I bet you can.
So Bill got me really curious about this column chemistry. Do you have any more information that you could share?
Sure, Jen. We designed this column last year, and what it is a column that is really optimized as far as the HILIC chemistry and the particle morphology. That meaning mostly the pore size of the particle is ideal for the separation of glycopeptides and glycoproteins.
Great. Do you have any examples?
Yeah, I can show you.
Okay, great.
Jen, here's a really good example. This is a separation of glycopeptides. And what we've done is we digested a protein, and on the top separation, we're looking at the separation on a reverse phase column where we basically have all the glycopeptides pretty much coming out under one peak. Whereas if we run this on the glycoprotein BH amide column, we can see that we get a really nice separation of those glycopeptides. It's really clear when you zoom in on these chromatograms. In this example, we're looking at the intact protein. And what we can see is that based on whether the protein is occupied with between 2, 1, or 0 glycans, we can distinguish between those in this separation on this HILIC column.
So you can really do all that work with just one column?
Yeah, it's a pretty cool column, Jen. In addition to those types of examples, it'll do things like looking at subunits of antibodies, as well as looking at really extended release N-glycan structures.
Wow, that's pretty impressive.
Yeah, it is.
Thank you for your time, Steve.
No problem.
Bill, what are you doing over there?
Jen, have you heard about these virtual reality goggles? They're super cool. But I was listening to you and Steve, believe it or not, and you know, what used to take all of these columns can be done with a single column, enabling people to find out where the glycans are located. Unbelievable. But you know what? These are also pretty cool and unbelievable.
I thought sugar was only useful in coffee. As we know, pharmaceutical companies have many biotherapeutic drugs in their pipeline, and they need to know not only the glycan structure, but also their location. As we have seen with this new column, this type of work no longer needs to be mysterious or highly complicated. Don't get me wrong, it is still not a piece of cake, but new technologies are starting to not only make this type of work easier, but we are seeing some astonishing data. Check out the links below to read more about the new column that was featured in the applications we showed in this episode. We hope that you have learned a lot in this glycan series. From theory to new tools, hopefully tackling frequently asked questions about this type of work. Therefore, we felt that it was only fitting to wrap up the series with a full interrogation. Does this work for really difficult, real-world samples? You have asked, and we have worked on these problem children. So join us next time as we go behind the science to look deeper into those that challenge us.